Today's lesson is on the derivatives of exponential and logarithmic functions. So before we even start talking about that, we need to talk about e. Most of our our logarithms and exponentials, sorry, our logarithms deal with log base e, and e is a constant. It's 2.7 something something something, so it is like pi, which is 3.14. But what's nice about e is its own derivative. So that makes it really nice. And here's that rule. If you take the derivative of e to the x, then you will get e to the x. So what we're going to do now is we're going to work with that fact and some chain rule information to find some derivatives. So let's go ahead and start with the first one. And again, remembering the rule that the derivative of e raised to the x is e raised to the x. So in the first one, we have y is e raised to the 2x. I'm going to rewrite that as a chain rule. And the inside is what do I actually do to x first? And what I actually do to x first is I'm going to multiply it by 2. And then the outside is what do I do with that once I have it, which is e raised to the. So when I take my derivative, I need to remember my inside-outside rule, my chain rule. And so the derivative of the outside is the e raised to the. So, and that's still just e raised to the 2x, exactly what I had before. And then I need to multiply by the derivative of the inside, and the inside is the red 2x, and the derivative of that is just 2. And again, if we wanted to simplify that, we could, and that would be 2e to the 2x. So in a multiple choice question, it would look like this. However, you're welcome to leave it the way I did with the red and the blue. So let's try the next one. Find the derivative, dy dx, of y equals e to the negative 5x. I'm going to rewrite that with my inside and my outside. My outside is the e. The inside is the negative 5x, my exponent. And now I'm going to find my derivative. So dy dx is equal to the derivative of the outside is e raised to something, and it will remain e raised to negative 5x. And then I need to multiply by the derivative of the inside, and the inside is negative 5x. The derivative of that is negative 5. And again, if you wanted to simplify that, or you're looking for a multiple choice answer, it would look like this. Moving on to the next example. The next one's not bad either, but I would probably rewrite this before I started. And the problem that I would rewrite is this square root of x. And again, when I'm dealing with calculus and finding derivatives, that's not very friendly. So I'd rewrite it as x raised to an exponent, and the exponent when I'm taking the square root is 1/2. So when I rewrite this with an inside and an outside, my outside is e raised to something. My inside is x raised to the 1/2. So I'm going to take my derivative, and again, the derivative of e raised to something is just e raised to something. So I'm going to have an e raised to the x to the 1/2. I'm going to rewrite it, though, as square root of x, because right now I don't need it in that power rule form. Then I need to multiply by the derivative of the inside, and here's my inside, and that derivative is 1/2 x raised to the 1/2 minus 1, which is negative 1/2. Again, if you're working that problem out just for me, when you don't need to find your answer in a multiple choice question, you may leave it like this. Otherwise, the multiple choice answer would look like this. I would have e to the square root of x all over 2 square root of x. And that's taking that x to the negative 1/2 and moving it to the denominator. The next one that we're going to look at is no longer e raised to a power, but it's going to be a number raised to a power. So on the next page, this is the derivative that we're going to be looking at. Something like 2 raised to the x. And that derivative is going to be the same thing. So if I had 2 raised to the x, the derivative would be 2 raised to the x times the natural log of 2, whatever that base is. Now this is actually what's happening in our derivative of e to the x. But when I take the derivative of e to the x, it would be e raised to the x times the natural log of e. But what is the natural log of e? Everybody knows, hopefully, that the natural log of e is just 1. So I'm actually just multiplying by a 1. So go ahead and go to the next page. And here is what we're finding the derivative of, y equals 8 raised to the x. Now, our base is constant. Okay, our base is what's constant right here. And that is our 8, whereas our exponent is what is the variable. Our exponent is the variable. So let's take a little side trip over here to the right. These things are very, very different than the power rule. So the power rule is when I have the derivative of x cubed, I know I take the exponent comes down, and then this new exponent is the old exponent minus 1. And that's when the base is the variable, and the exponent is the constant. But what we're working with is opposite. We've switched those two things. So when we look at the exponential rule, my base is a constant, and the exponent is the variable. And that's when we're going to use this rule that we have here. So I'm going to go ahead and I'm going to rewrite this in terms of my inside and outside, even though I don't even have an inside and outside, so I'm not going to rewrite this. So when I find this derivative, dy dx is going to be the 8 raised to the x again times the natural log of 8. And that is it right there. That's your derivative. So that's all we have to remember is we're actually multiplying by the natural log of the base. So let's look at the next one that is a chain rule. So for this one, I'm going to rewrite it as my outside is actually 9, and the inside, the first thing that I do to my x is the opposite of x. And we're going to go ahead and treat this exactly the same way as we did the one before it, except we have a chain rule. So I have dy dx is going to be equal to, again, I have my 9 raised to the negative x is going to remain as part of my derivative. And then I'm going to multiply by the derivative of the inside. Sorry, I'm going to continue with my derivative. I would go ahead and then multiply by the natural log of 9. That's all part of the derivative of the outside. I apologize, I was going out of order. Now multiply by the derivative of the inside. My inside is negative x, so that derivative of negative x is negative 1. If you wanted to rewrite that, I would just put the negative on the outside, negative 9 raised to the negative x times natural log of 9. And our next one, we have another chain rule. So when I rewrite this, I have y is equal to, the outside is the 3, the inside is the cosine of x. And let's go ahead and find that derivative. So dy dx is that 3 raised to the cosine of x. And then I need to multiply by, I got to finish the derivative of the outside, which is multiplying by the natural log of 3. And now I need to multiply by the derivative of the inside, which is the negative sine of x. And I can rewrite that if I'd like. Again, not multiple choice, leave it be, just don't mess with it. I would probably put my negative sine of x in the front, and then my 3 cosine, 3 raised to the cosine of x, and then times natural log of 3, just to separate what each thing is. So I'm only taking the natural log of 3, I'm only taking the sine of x, and 3 is raised to the cosine of x. So over on the right, I talk about simplifying and what not to do, and I'm going to talk about that more in depth here with this last example. So with our last example, let's rewrite this. This is really y is equal to my base. My outside is really 2 raised to something, and the inside is the 5x. So with this one, when I find my dy dx, again, I've got a chain rule. So I'm going to start with the base. 2 raised to the 5x. The derivative of the outside is 2 raised to the 5x times natural log of 2, natural log of my base. And then I need to multiply by the derivative of the inside, and my derivative of the inside is 5. So what is meant by this don't oversimplify is, because I don't want you to make a mistake, these two right here, that is not the natural log of 10. This is two distinct things. It is the natural log of 2 times 5. It's not the natural log of 2 times 5. So this is not the natural log of 10. If you're unsure, leave it alone. Don't mess with it. Okay, and again, the 2 is being raised to the 5x. I'm only taking the natural log of 2, and then I have this 5. If I were to rewrite this, the only thing that I could do is I could write that as 5 times 2 raised to the 5x times the natural log of 2. There is one more thing that I could do, because 5 times the natural log of 2 is the same as the natural log of 2 raised to the 5th. But I don't think that's any more simple. So these two things are equal, but not necessary to actually use that rule right now in simplifying. So our next derivative, I'm going to go back to the first page and identify the derivative we're going to be talking about. So on the first page, the next derivative that we have is we're going to deal with natural log derivatives. Again, here's a derivative you need to memorize. All of these we need to memorize. The derivative of the natural log of x is 1 over x. Another way to write that is we would have the chain rule, and that's down at the bottom. If I have the natural log of some function u, whatever it is, I'm going to take my 1 over u and then multiply by that derivative. So that is how we are actually dealing with the chain rule right there. So going back to where I was, I'm trying to find the derivative of y equals the natural log of x squared. So let's rewrite for our inside and outside rules. And again, the inside is what do I do to x first? And the first thing that I do to x is I square it. The outside is, what do I do to that after I've done it? And that's natural log. So this is my function. Let's take this derivative using that rule. So the derivative of y with respect to x, the derivative of a natural log is 1 over whatever I'm taking the natural log of. Then I need to multiply by the derivative of the inside. My inside was x squared, and that derivative is 2x. Now, something like this can be simplified, and dy dx ends up being, I have a 2x over x squared, which is really just a 2 over x. So that is the simplified version of the derivative. Now, over to the right, there's a box, and it talks about simplifying before we take the derivative. Now, if you know your log properties, then I would use them to your advantage because they would make everything so much easier. So the rule that I'm going to use is what I just did in the previous problem when I was simplifying. Whenever I have an exponent here that I'm taking the natural log of something raised to a power, I can rewrite that by pulling the power down in front of the natural log. So this is really what I have. If I take this derivative, I do not have a chain rule. There's no inside, there's no outside. I just leave my constant where it is, and I multiply it by the derivative of natural log of x, which is 1 over x, which is 2 over x, exactly what I got when I did it the other way. However, there's fewer mistakes made when I do it this way where I simplify first. In the next one, I'm going to go ahead and talk about what these log rules are. I apologize. If you do look at the last page of your packet, the properties of the logarithms are there. If you need to take a moment to look at those, please do. Pause the video, look at your properties of logarithms. I'm going to use the properties of logarithms here. I can rewrite this as the natural log of 10 minus the natural log of x. At this point, I can take the derivative. When I take the derivative of natural log 10, I need to think about what natural log 10 is. Well, natural log of 10 is a number. It's a constant, which means when I take the derivative of that, it's just 0. And then I'm going to subtract the derivative of natural log of x, which is just 1 over x, which means this is just negative 1 over x. Now, you could have done this with a chain rule, but you would have to rewrite the inside as 10 times x to the negative 1, and then deal with the chain rule that way, which is fine if that's what you want to do. That will work as well. I'm going to go back to the first page to show you the next rule that we're working with. And the last rule that we have is this one here, and that is the derivative of log base a of x is 1 over the inside, whatever this inside is, and then also in our denominator is the natural log of whatever our base was right here. So let's go ahead and do that example. So we have this, and I do have a chain rule, so let's rewrite this. So I have my inside and my outside. The outside is the log base 4, and the inside is going to be my x squared. So in dealing with this one, I have my derivative. Again, we need to memorize this rule that we had to use, and that's going to be the derivative of a log is 1 over whatever I'm taking the log of, which is my x squared, times the natural log of my base. And my base in this case is this 4. So that's the derivative of the outside, and now I need to multiply by the derivative of the inside. My inside was x squared, so the derivative of the inside is 2x. Now this can be simplified. So if I rewrite that, my 2x can go on top, and then I have an x squared natural log 4 underneath. I can simplify my x on top with one of the x's on the bottom. That makes a 1, so I have a 2 over x natural log 4. And I can simplify this a little more, and on a multiple choice question, it probably will be simplified a little bit more. So that would be 2 over x, and I can rewrite natural log of 4 as the natural log of something squared. And natural log 4 is the natural log of 2 squared. And so the reason I'm doing that is my 2 stays on top, my x is still there, but I'm going to use that I have the natural log of something squared rule. I can bring this 2 down. So I have times 2, natural log of 2, and again, we now have a special version of the number 1. Looks pretty silly, but it's still a 1. And that leaves me with 1 over x natural log of 2. And that would be how a multiple choice answer would look. So on to the next page. We are still dealing with a log with a different base. This is a log base 10. A lot of times mathematicians get lazy, and when we have log base 10, they just write it as log. When there's no base there, it is automatically a base 10. So first I'm going to rewrite this with my inside and outside. And I'm going to rewrite this inside a little bit differently. So I have log base 10 of something, and this x plus 1 is taking the square root of that. I'm going to write that, the x plus 1, as being raised to the 1/2. And I'm taking the log of that whole thing. So first we're going to leave it just as it is and take the derivative, and then the next thing we're going to do is we're going to simplify that first and then take the derivative. Okay, so that's the next thing that we're going to do. So right now we're going to leave it as this mess, and let's go ahead and find our derivative. So dy dx, take the derivative of the outside, and that is a log, so it's 1 over, and it's exactly what the inside was. I'm going to rewrite it though in square root form again. So the inside, and then times the natural log of the base of our logarithm, which is 10. And then I need to multiply that by the derivative of the inside. My inside is x plus 1 raised to the 1/2. So that derivative is 1/2 times x plus 1 raised to the negative 1/2 times the derivative of the inside of that, which is really just 1. So I can simplify this sum, and I have a negative exponent right here. So this term can actually go to the denominator, and it's the square root of x plus 1. And I have another square root of x plus 1, so when I end up multiplying those together, the square roots are no longer there. Square root of x plus 1 times the square root of x plus 1 is just x plus 1. So I just have a 1 on the top. I'm going to have a 2 down here. I'm going to have an x plus 1 raised to the first power times the natural log of 10. So that's the most simplified I would probably do with that one. Now, in this last one, we're going to use our log properties first. And once we use our log properties first, it's going to make it a little bit easier to deal with. So the first thing that I'm going to do is I'm going to take this power and bring it down out front. So 1/2 log base 10 of x plus 1. I'm going to rewrite it identifying what my inside and outside are now. So my outside is log base 10, and my inside is the x plus 1. And again, my derivative of inside now is just 1, which is making it much easier. So my dy dx is going to be 1/2. My derivative of the outside, or the log base 10, is 1 over the inside of my log base 10, which is x plus 1, times natural log of the base, so natural log of 10, then times the derivative of the inside, and the derivative of the inside is just 1. And if you compare what we have here with what we simplified in the first one, we really have actually done all the simplification that we can already. All I can really do is make sure that that 2 is under the same fraction as my x plus 1 times the natural log of 10. Now, below here are all the properties of logs. You should have already experienced all of these. Whether they stuck with you or not, I'm not sure, but I would like them to stick with you a little bit more. So please be sure and kind of study up on these so that you know these log properties, simply because they're going to make your life easier. If you know those, and you can use them to simplify before you start taking a derivative. So that's your lesson on derivatives of exponential and logarithmic functions. I hope you have a wonderful evening.